Sup guys, welcome to today's show. So today we're gonna start a new project where I'm gonna develop my own HTML. And the purpose of this project moving forward is to create my own HTML, my own CSS, and use that to create console-based graphical user interfaces for C applications. But there's a long way there, and today we're going to focus on parsing the HTML. And we're going to code this in C. I will inform you about what we're going to do when we're going to do it. So I'm going to use bash.bs to create a template. And if you don't have bash.bs, download it from the repo. It's repo.drbirch.com. And maybe I should increase the font size just a hair. So let's see. Let's do 14 bold. And set this to full screen. All right. So I have a whole episode about bash.bs. Search for build system. So I will call this project Hyperbird, and hyper is from the hypertext markup language, HTML. And it's the default C template. And I'll go into the Hyperbird directory and, as usual, set it to my home. And we have makefile and simple.c and .h. I will go into Sociopath and find my directory. Let's see. Where am I? Hyperbird. Ah, there it is. So I will launch this in VS Code, where we will be doing our development today. So let's see. Let me just make a few adjustments. Let's see if the makefile's okay. I want to change the standard to C23. And you need the latest GCC version 14 something to be able to use C23. Otherwise you use C2X, which is the default. Right, that's good. I'm also gonna change these macros. So our int 8 is 1, this is 2, this is 4, and this is 8 for the number of bytes that these data types represent. And yeah, that's okay for this. All right, so how to do this? I'm gonna code this thing a little bit influenced by the functional paradigm. Not entirely, not book correct, but some influences. And I'm going to start by defining a data type for strings. So let's create a struct s string, and the string in this representation is, let's see, I want to have a length. So let's say we have an int 16 length, and we'll have a pointer which points to the current position. And then the actual data. So let's make this. Let's do this. Int 8 data, and we don't define a number of bytes. So we will allocate using malloc. And then I want to do a type definition. So let's do struct s string, and this will be a string with capital S. Okay, so this is how we'll handle strings, and this will be which is called an immutable variable or data type. Which means that once it's created, it cannot be changed. So every time we need to update this, we will destroy this and create a new one. And why do we want to make it like this? It's for security reasons, basically. When we use immutable variables, it's much safer. All right, so now we have a string. What else do we do? Well, let's see. We need to have tokens. So basically, let me show you what I have in mind. I want to create a simple HTML-like language, which looks, let's say we have body, and we have bold, and then we have some text, and then an ending tag for body. So what we need to do is we need to put this through a lexer. And if you watched my episode about creating a compiler, the first step is coding the lexer, which transform this into tokens. So we will have, in this case, we will have if we make a simple table, we have token, let's see, value. So this first body tag will be tag start. Let's do one more here. Body, and then we have tag start bold, and then we have a text token with the value text, and then we have tag end bold and tag end body. No, not up there. There. So that is our first mission, to be able to parse this with our lexer, turn it into these tokens. And all of these are different data types. And these are their values. All right? So let's define our tokens. Maybe we should even put that in an own file. Let's see, because it's probably gonna be quite many in the end. Let's do that. Let's do a new file and let's call this tokens.h. And we will include this in our Hyperbird. And if you don't have birch utils, by the way, you can also find that in the repo. So we'll include our local tokens.h. And let's start by defining what a start token is. So we'll do a struct s tag start. And this will have a tag type. So that will define what kind of tag it is. And it will have a value which will be, should we use our string data type for this? No, I don't think so. We are going to use that, but I want that for a different purpose. So let's just do this value. And later on, we will also have attributes here. So if you know your way around HTML, some tags have additional metadata to them. So for example, you can do font color equals red. So font is the HTML tag, and color is the attribute, and red is that attribute's value. So let's put it in a comment for now. We will have something like attributes, something like this. But that will be later add-ons if needed. For now, this will be it. We will type def struct s tag start. Right, we need to it's complaining about int 8 because we have all the definitions inside of this file. Maybe we should go the other way around, but we can't really do that, can we? This is not very nice, but I think we will have to do this for now. I will figure out a better solution later on. And we need to define what a tag is. And that will be an enum. So let's do enum e tag. And here we'll list our different HTML tags. For now, I will only add a few. So let's say, for instance, that we have HTML, which is number 1, and we have body, we have, let's use this bold thing. And let's start there. I will type def enum e tag as tag, like so, and the error has gone away. So basically the tag start is gonna contain HTML, for example, and the value in this case will be HTML. Like this, as a string. So we have something to compare to when we need to parse it. So that's start tag. We also need a corresponding end tag. So struct s tag end. And this will be the same tag with a type int8 value. Type def struct s tag end, tag end. And then we have a third category. Let's add one of these here. Let's say BR, for example. BR is a break. It creates a new line inside of the page. And BR does not have an end tag. So it's basically its own end tag. And when you code a variant of HTML, which is called XHTML, you usually do like this to indicate that this is both open and close for this tag. And this is the style that we're going to adopt. So let's create a third category for self-closing tags. So struct s self-close. And this will also be tag with a type, int8 with a value. And we want to type def struct s self-close to self-close. Okay, so now we have defined the different tags. Let's create a token as well. So the token can be any of these. So let's see. First we need to define an enum for the token type. So enum e token type. And we're going to have only a few. It'll be 4 for now. So we will have a text token. We will have a tag open, tag close, or we Do we really need to define this? No, we probably don't. Let's just do tag like this, and then we can define it inside of the type like we have done here. So type def enum e token type, and this will be token type, like so. And now we can define our actual tokens, and this will be struct s token and the token will have a, let's see, a token type. And then we will either have a text or a tag. I think I will do this, by the way. It will make other stuff easier if we do tag open. It'll be a little bit of duplicate code, but it will help us in other ways. Tag close, self close. Let's do the same here. Self closed, self closed, and self closed. All right. So now we have the token type. Now I want to do something like, so in the later C standards, we should be able to just do union like this. And then we define different things. So we will have a, let's say, tag end, and tag, let's start with tag start, by the way. Tag start. Let's keep the same names, by the way. Tag start, tag end. Self-closed is okay. Self-closed, tag end, tag start, yeah. So we have tag start, we have tag end, and self-close. We can't call this self-closed because we are already using it up here. So it will collide. That's why I did start and end. But what can we say here? Self. And we also need one for the text. Which we haven't defined yet. But it will be text. Text. No, we can't use text. Text token. I don't like this name standard, but it'll be all right. All right, so a union basically means it's like a structure, but we will not have all of these at the same time. We will be able to use one of these, so either this, or this, or this, etc. And since a token is only one thing, it makes sense. And what should we call this thing? Well, this is the actual token, the contents maybe. And that's all for this. So we'll do type def struct as token. And let's also create an own data type for tokens plural. And this will also be an immutable structure. So we'll do struct as tokens with an S. And this will have a token I don't think we have used tokens with small letters, have we? And we also need to know how many they are. No, wait a second. Let's start with that. We need to know the size of this thing. So let's do an int16 length. And well, we're gonna have token. Let's do t's. So T for token and T's for plural. Right. And type def struct as tokens and tokens with an S. Okay. We only have one more data type to define at this point, and that is this text token thing. So what will that be? Let's make it a string for now. Type def string text, like so. Okay, we haven't defined that in here. It's annoying with all this duplicate code. I will figure something out, I promise. But I don't want to dive into it too much at this point. Okay. Why do we have an error there? Okay. It doesn't allow for this. It does with strings, but apparently not with our tokens. So let's make this a pointer instead. All right. So how do we create any of these structures? We need to create a couple of constructor functions. So let's start by creating this string structure. Let's do constructor functions. And we'll use this syntax. We'll call them make and then whatever it is. So make string, for example. And this will return the string. And I think I'm going to use pointers. So make string. And do we want to put something inside of here? Yeah, we kind of need to. So let's do int 8, like so. And I also want to do, let's wait with that, by the way. Okay, let's create this function. So it'll be a string, make string. It'll take a int 8 pointer input. We need to have a pointer. And let's do some sanity checking. Let's assert that we have an str. And that the length of this, so maybe we should create a function that checks the length. Well, we can use the standard C library, but it's kind of good to have our own as well. Let's call it string len. And let's make it instantly. So int 8, no, it will return int 16. String len, and it will take an int 8 str. We need to assert that we have an str. And we need to have some kind of counter. And we need to have a pointer. Which we'll call p. And then we'll do a for loop where we set p equal to str. We set n equal to 0. We're going to loop as long as we have a p. And at each iteration, we're going to increase p. We're going to increase n. And that's all we need to do. And then we return n. Now we have a string length function of our own. So let's do int 16 string len int 8 star. And we can go back to our make string. So what do we need to do here? We need to allocate for this string to begin with. And how does this thing look? We're gonna have length and the current position, and the rest is the data. So we need to first calculate how many bytes we need. So let's do an int size, and the size will be equal to the size of a struct s string. So that basically corresponds to this part, and then we need to take into account the number of bytes in the string. So maybe we need to do, well, let's do this. We do create an n, and we set n equal to, no, we can't do that. We must first assert that we have a string, right? So let's remove this, and let's assert that we have a string. Then we will set n equal to the string len of str, and now we can assert that we have an n. And when we have an n, we can plus that to our size, and we have the size of the structure. So now we can set p equal to the int 8 of malloc size, and we assert that we have a p. Okay, so now we have an empty structure. Let's also zero it out just to be sure. So we'll give the int 8 version of the p and the size. And now we'll take the length, and we'll set it to n. We'll take, let's wait with the cur. For now, we will copy into this int 8 thing. So we'll have a copy function. String copy, and we want to copy into p data, and we want to copy from the string n bytes. And then we can set the current position equal to p data, and we'll return p, like so. And there is our constructor function, but we need to create this copy, this string copy thing as well. So let's see, shall it return anything? No. We will have a void string copy, which will take an int 8 destination, an int 8 source, and an int 16 size. And this function will be very similar to the one that we wrote above. we're gonna have an int 16n and an int 8p. We need to assert that we have a source and a destination and the size. And then we can set p equal to, we don't just need a p, we need a p for the destination and a p for source. So let's call this D and S instead. So we'll set D equal to destination and S equal to source, and N equal to size. And we're going to continue as long as we have an N. At each iteration, we will increase the D and we will increase the source and we will minus the N. And what are we going to do inside of this loop's body? Well, we're going to take the current position of D and set it equal to the current position of S. And then we'll return. Easy peasy. So we will have a void string copy, and it'll take an int 8 star, an int 8 star, and int 16. Like so. What's next? Well, I want to have one more string-like function, but it should be dealing with our own string data type now, not the regular string. And I want to have a function which is called get, which chops off 1 byte from this string. So the first byte, and it returns a new string. No, let's see. Yeah, it needs to return a tuple with the byte that we chopped off and the new string, which means we need to define a tuple data type as well. So let's say struct as tuple it contains a string, and it contains an int 8, which is a char. So type def struct as tuple. And our get function will return pointer to a tuple, or maybe it will just return the tuple. It'll call get, and we're going to supply this thing with a string. Yeah, with just a string. And I want to create a destroy function as well for this string. So let's say s destroy. So the s will be the string data type that we defined. Since we're gonna use immutable data types, we need to have destroy functions for them so we can clean up the memory when we alter stuff. And that will be a quite simple thing. We will just do void s destroy, and it takes a string s. Did I make it a pointer? I did not. This should also be a pointer. And let's see, it contains length current data. Yeah, we can just, we don't even need a function actually. We can just create a macro in this case. So let's go here and we define s destroy. We have an s, and we'll just do free s. And I still want an own function for it because we're going to have a couple of these destroy functions, and not all of them will just call this free function. So we can remove this. Okay, let's create this get function. So it will return a tuple, it will be called get, and we'll have a string s. We'll assert that we actually have an s, and we need a tuple for the return value. Well, let's wait by defining that. Let's define the contents separately for now. So we will have a string new, and we will have an int 8c. So we need to assert that we have an s. How do we deal with failures? Well, we can just return a tuple with all zeros. So if the s length is 0, then we will define a tuple with the return value all zeros, and we'll return that. Okay. Otherwise, we should be able to get something from this one. C is going to be equal to the current byte in the string, and our new will be equal to a copy of that first thing. So let's say this is an S copy, and we'll give it the S. And if we can't do this, let's do this instead. Let's use the very hated goto. So goto fail. And we'll do the same here, goto fail. And at the bottom we'll define fail, and here we want to do tuple ret is equal to all zeros and return ret. Maybe we should call this error instead. If we do get a new copy of this string, we want to make sure that the new copy has moved the current position one step. So it would basically contain the same stuff, but it will nevertheless be one less character, which means we also need to decrease the length. And then we want to create our successful return value. And what we have an S and a C. The S will be equal to our new, and the C will be equal to our C. And we want to destroy the old one and return ret. Okay. So we have written quite a lot of code without testing it. So let's see if it works. Let's create a string S1 and S. Let's just do S for now. And let's have an int 8c. And we'll set S equal to make string. And we'll have something hello world. And then we want to set we need to have a tuple as well. We'll set t equal to get, and we give the s. And if this errors, which means we will not have a C inside of it, we can print error and exit. Otherwise, we want to print C and let's also print the new string that we get back. So new is equal to this. And we'll give our, no, that's not right. And we'll give our C and our TS return 0. All right, let's see if we made any errors. Let me just save all of these files. Okay, a couple of errors, but not too many. Right, we never created the copy function. Let's start there. So let's define our copy function. Let me see how I used it. Copy, copy, copy. Not string copy, that's for indate stars. But we did use, where did we use it? Right here. So it takes a whole structures, a whole string structure, and makes an exact copy of it. Simple enough. So let's define void scopy, and it will take a string, and not void, by the way. It should also return a string. And we have a length and a cur and a data. Well, let's start with the length and the data. That's simple enough. So we'll have a string scopy and a string s. We want to assert that we have an s and that it has a length. And now, what do we want to do? Well, we need to have a pointer. And we need to be able to calculate the size. And the size will be equal to size of struct s string plus length, and we will allocate for this and let's assert that we do have a p as well. Okay, so far so good. Yeah, we can assert that. If we have, the only way it can fail basically is if we have some kind of, we have run out of memory, and in that case something is enough wrong to be able to abort. Okay, now it gets a little bit complicated because, well, if this has never been updated, if we have never run the get function on it, it will be very easy. We just copy the whole stuff. But it's a little bit trickier since, let me show you an example. Let's say we have the string hello world, and this size is equal to 5, 10, 11. So if we want to copy this, we just copy these 11 characters. Let's say cur is pointing towards the H in this case. But now we run the get function twice, for example. So we chop off 1, 2. This will go down to 9. The cur will point to L. But the data will still be hello world, right? Because we don't delete the data. So if we want to make a copy of this, we have the 9 here. Well, no, we can't. Well, yeah, well, maybe we can copy 9 from cur, and that will work, right? Okay, never mind. It was quite simple after all. I was too hung up on the data part of it. So let's see, let's zero out our new thing. And by the way, I just want to double check one thing. Make string. Right, this should not be int 8. This should be string. Alright. So now we need to fill in all the blanks here. Let's start with the length. Pretty easy. The p length will be equal to the s length. And the data will be pretty easy as well. We'll just use our string copy function to copy into p data from s cur, and we'll use s length bytes. Simple enough. But we have one left, and that's the cur. What should we point that to? Well, we can point it to our new data That's pretty good actually. The data will not contain any additional overhead. So we'll just do p cur equal to p data. Nice. And now we will do s destroy on the first one, and we will return the new one. Okay. Still have one error. %s expect argument type char, but argument 3 has type string star. Right, we need to go one level deeper and grab the cur. So this should be t.s arrow cur. And what is this? C may be uninitialized, will it now? Yes, we have not allocated for that. Let's remove this instead and just show. No, let's do it. This should be C is equal to this. And now I believe it will compile almost. Incompatible types. When assigning to type int 8 from type tuple. Okay. Okay. This should still be T, but the C should be equal to this, right? No, not an arrow. T.C. Okay, it compiled. Do you think it's going to work? I think I do. Oh, double free. That's not nice. How does that happen? We don't have too many of these frees. The only thing is s destroy, which we use here and here. Let's see. We destroy s, and here we destroy s. So we get T. That's weird. We make the string and we get s. So we do all of this stuff, create a new thing. Wait a second. Right. When we do this new thing right here, we destroy the old, right? So let's not destroy it inside of the copy. Alright, now it should work. Almost. We do get the H of hello world, but we did not really get the other thing. It only copies the H a lot of times. Interesting. That should be our string copy function, which doesn't work properly. Ah, right, we increase source. We should increase S instead. All right. Now it works. So it chops off the H, and the rest is this. And since you asked me to make the episodes shorter, I think we will stop right here for today. But this will be a new series that we're going to continue, so please like and subscribe if you think it'll be interesting. And you will see when I release the next episode. And thanks for watching. Thanks for today.